So yeah, here we were taking a look in our previous lecture, how hot is the center of the Earth, and then asking you to add your discussions here in the announcements. But here we can go back in the course now, or follow the breadcrumb trail, announcements, general, or back to the central column of the course here. See my little hand up there, little arrow? When it turns into a hand, you know what that means, okay? So I just want to make sure that, that we're covering all the basics. So there's our announcements. The syllabus is right here. And hopefully you've taken a look at the syllabus. There we go. Nice. So there you see the office hours are 4 to 5 p.m. in Grizz House 08F, and you can the lectures will be recorded in HBO 6 Tuesdays from 2:10 to 4 p.m. and you're welcome to come to those if you'd like, or you can pick the lectures up online. I try to keep the segments to 15 or 20 minutes. Sometimes they might run to half an hour, 40 minutes, but so that you can kind of pick them up a little at a time. Then key points, because we will cover a lot of material, key points will be brought to light. So I'll have a review, and then the tests, you'll be able to preview the tests and then maybe go back and review the material, so that you should be able to do quite well in this course if you pay attention and keep up with the material. Now, as far as the math prerequisites, we're going to have specific math, so that I'm not going to ask you to do a whole bunch of variable equations, or it's not going to be a difficult mathematically. It's just going to basically be dimensional analysis and then quantitative. And the course book now, it's going to be geothermal, where is it here? Enhanced Geothermal Systems. No, where's it at? There it is. Yeah, Smart Guide to Geothermal, How to Harvest the Earth's Free Energy for Heating and Cooling. And that's a great little book. It's not a really expensive book. That's the whole idea, was that some of these textbooks were $150 used. So this one's something that will get you going with your ability to harvest the Earth's temperature and put it to work in your own backyard. And it's a paperback, so I think it's $30 or something like that. You might be able to get it used. We're working on that right now. The bookstore is in process. They're moving it. A lot of the stuff is gone right now, so if there's any problems with you getting that textbook, let me know, because we're there. Last I heard that it was ordered and it was supposed to be in, so I'll check on that again today. It wasn't in yesterday when I looked. Okay. Now the other not required. Actually, I think that you do just fine if you take advantage of the internet and the digital here. Learning assessment, participation in grading. So here there's going to be a lab. Actually, we're going to have 2 labs. We're working on a second lab that Brad and I are right now. Brad Layton, the director of the energy program, and myself, we're going to do an actual earth or thermal battery. So some storage, not just using medium temperature, but it's going to be a medium temperature lab, and we'll talk more about that. So I try to be, shall we say, very lenient. I mean, there is a competitive aspect to the course, so there is a requirement. You have to do. You got to do a little bit of work, to get the grade, to show, that you've gained the knowledge, the wisdom. But if there's issues like we have with electronics, sometimes the computer issues, or the internet goes down, which happens here at the university, then we just stretched the due date, so it's not a real big deal. So go ahead and on your own here, this online tutoring here at Montana, umontana.edu. Good stuff for your paper. And there'll be a paper later on. You'll see all that in the central column. Okay, let's go back to the course here. Let's look at your syllabus. Now, if we get, this is all in the header right up here, so this is just the introduction to the course. Now the actual course begins down below here, and you're not supposed to see all this stuff because this is the student view, so maybe I'll switch my role to the student, and let's see what you're going to be seeing here. There we go. So, topic 1. Question?
Student introductions.
Yeah, right here. Student introductions. Student introductions. Start a thread with your name. Put personal contact information you want to share with classmates or the world. You can also put a blurb about your interest in energy, your background, etc. And welcome to Geothermal Energy. That's me, Jonathan Bowe. And this is where we can communicate and exchange ideas about areas of geothermal energy that are of interest to you individually. First, tell everyone why you're taking this course, and what special interests you would like to explore in the world of geothermal energy. I'm Jonathan Bowe, and this is my 5th year teaching Intro to Geothermal Energy here at Missoula College. My special interests in geothermal are residential earth coupling techniques. There's a vast amount of thermal energy available to us all at 6 feet underground. All we have to do is harvest it. I'm currently putting the finishing touches on an earth-coupled geodesic complex up in Stevensville, Montana. I look forward to sharing the information I've gained over 43 years of experimentation in applied geothermal concepts for heating, ventilation, air conditioning, and solar photovoltaics. So there is a cooling aspect that we've found out in some of our practicums, summer practicums that we have, energy practicums, that you can actually participate in those if you haven't already. And we found that if you keep a solar panel cooler, it actually pays for itself as far as the extra energy it takes to run a fan to cool it will increase the output such that you get the free fan basically, and improved productivity or better output from the photovoltaic panel. So we can link the photovoltaic panel to the earth, store energy, store heat, and at the same time get more electricity. So I'm hoping that you all will have some ingenious input to this course in your areas of interest. Anyone that comes up with a concept or application of geothermal that I haven't heard of is going to get an A+. So here I am in front of my geodesic complex. You can see the solar collectors over here that are set up on convective gradient. And what's kind of nice about this solar thermal is if you put it below your living space, you'll get a cold air sump so that you won't get backflow, or you won't get cold air flowing into your house on those when it's 20 below zero outside, so that the cold air just kind of traps or sumps into the solar collector. And then when the sun heats it up, I uncover this when it's cooler. This cover comes off, and then the sun heating that, and that's set at about 45 degrees, which is the winter angle of incidence, 90 degrees at winter solstice. It's about 46 degrees, I think. So anyway, that solar heat comes ripping into the house, and there's another bank of solar over here, and this is all passive solar up here. It's all shielded right now because it's summertime. But and then it's all set on a convective gradient down in the earth. Most of this house is underground. So this is the daylight side of the house right here. Hey, looky here. Lynn Farmer. Hi, Lynn. My name is Lynn Farmer, and I plan on receiving my associate in energy tech after spring semester. I have a Bachelor of Arts in elementary education and special education. I have my master's in counseling and ed leadership. I've been working in public schools going into my 33rd year. I have always been interested in sustainability. I truly enjoyed Jonathan during the summer practicum and was excited that he was teaching this course. Oh man, she's going to get an A. What do you think? Yeah. I spend all my spare time living off the grid. I enjoy anything outdoors. Great, Lynn. Well, welcome. And what I would do is I would say, hey, welcome, Lynn. Let's see. Let's get back to the central column. Oh, by the way, you'll see that this is highlighted in blue, so that tells you that's the current topic. As we go on down through here, you'll see there's topic 2 not available yet, and those will open up usually Thursday or Friday of the week. This week, this will be available to you, and you'll see that in this week there's also going to be a little quiz, development of basic units. But this tells you where you're at as far as this topic 1 will be available to you after this week, but topic 2 will be available and be highlighted blue. Okay, so just to kind of keep you on track. Let's take a look here. See if we can find Gary's post here. There he is. Sup? Nice, let's read it. Oh man, check the picture out, dude. He's styling, huh?
I'll be back.
Yeah. Gary's out there. He says, I'll be back. Yeah, he could be a Terminator, that guy. Let's see. Sup, 1 day ago. I should receive an Associate's Energy Technology in spring of 17. Wow, that 17's coming on strong. I'm pretty much the professional student. I hold a master's in journalism, environmental science, and natural resources. Oh, you got a master's in all of those? Dude, this guy rocks it. And a bachelor's in English literature, environmental science. You're going to be all over this course. I haven't worked a lot since moving to Missoula, and it seems like I'm on a publishing hiatus. I believe possibly because I am trying to shift fields from journalism to pure science. Pure science. Okay, no, that doesn't. Have you heard that song? Presently, I have several irons in the fire, from writing a novel with my wife, wow, to creating power with the natural forces of several magnets, sweet, nice, to looking at why biogases and other biofuels destroy engine and turbine components quicker over time as compared to fossil fuels. Yeah. And it's because the fossil fuels have been filtered. At present, there is no viable means to filter decomposition gases, or gas. So it is processed, impurities and all. This process not only decreased energy output, it decreases the life of the system. Because the impure gases corrode and rot nearly every component, from pumps to holding tanks to seals to valves to pistons. Now, the biggest component wear is noted in valves, whether they are in a tank and pressure valves or in the valves of combustion engines. I'm beginning work on a filter device that will operate on the principle of size exclusion chromatography. Sweet. In this device, swamp gas or sulfur and other impure gases will be filtered and the methane refined down to a nearly pure source. Getting the methane isolated from the other decomposition gases is the holy grail to making biogases, such as gaseous releases from dairy farms and municipal wastewater facilities, a drop in replacement for the natural gas and municipal systems. I don't know all that much about geothermal energy, but I'm sure that will change by the end of this course. Yay, all right. So, did you get to go to Hull Dairy? Were you there?
I've seen those there.
Oh,
I've been
sweet.
down there.
In the past, we've had the practicum students have gone to Hull's Dairy.
Hull's Dairy, there's the wastewater facility over here.
Mhm.
There's this landfill up here, there's a big dump that they just well, the first step I want to do is filter the water.
Okay, let me
Water off of it. If you put,
unread post. Ah, here we go. Got one more unread post. Wait a second. Oh, it's Matthew. Mr. Byrne. Hey, Matt. Let's check him out. Howdy. Matthew Byrne. He's got that nice picture going there. Hey all, my name is Matt Byrne, and I've been in the Energy Tech program for a while now. I have a few more semesters until I have my associates, and I will most likely try and throw my hat into the ring for a bachelor's in engineering. Sweet. I feel like there is a lot of untapped growth in geothermal energy, which I agree, Matt, and I want to know its secrets. What sparked my interest in renewable energy was that a family friend owns 40 acres off-grid in Washington, and after helping him for several years, I wanted to educate myself on techniques to improve his energy abundance. Nice. Also, after the summer practicum, I wanted to get a class in with Jonathan to pick his brain before I graduate. Nice, Mr. Bunn. So the brain is ready, man. Let's pick away. So a question, Gary's sitting in class here, and that's one advantage when you do come, and you don't have to come to the classes, but you're welcome to come, and then your input, you're right there, and you can ask questions. Question was, what is Unit 1? What's this all about? Unit 1 is just an explanation of scientific notation. And take a look at this paper here. So it's just your basic, Richard C. Bayless, he's a math teacher here at U of M, and just your basic scientific notation. So, nothing too complex. So take a look at those. There'll be a few questions, how here you multiply the exponents. Here you subtract the exponents. Here you add the exponents. So if it was a to the 5th times a to the 3rd, you'd have a to the 8th equals a to the 8th. And that's just because we're going to be working with we'll be talking about some nanotechnology, and then you need to have the exponential notation to give you so you don't have to write all the zeros. Then also see where I'm moving back in the course now, go back to the center up here at the top. This puts me back into the middle of the course. And then there'll be a development of basic units test down here. Go to, and this will be, the test consists of 20 questions covering the basic units used in mechanics, electronics, and temperature. Solutions to the questions will be available after everyone has taken the test. Instructions. This is an open book, open note test. So, I would say that take a look at the course here, the lecture today, listen to the lecture, take a look at the material that's in the central column, and then go for your attempt. So you have 1 hour, but you have 2 attempts. So you can go through it kind of, if I have a weak spot here and there, go find out the information, come back and take it the second time. And grading method is the highest grade. So I think everybody's gotten 100 on this test so far. So, and my goal, I got to say, is it's not to see how tough you are and see if I can trip you up. I just want you to have a little bit of basic information so that you can do the calculations that are necessary to how much pipe do we need for how many tons of cooling, how much cord are we going to need to run this compound lift system, some basic things like that, which will be good not only for geothermal but for just general in life. Okay. Now this won't, the quiz will not be available until Wednesday, August 31st at 4 p.m. Back to the course. So we wanted to take a look here at your lectures will be available to you. And right here, this one that I prepared.
Hey, greetings my fellow geothermal students. Welcome to Special Topics Introduction to Geothermal Energy Systems 291.51 Section 75285. Hopefully you've been able to access the course for fall 2016. Looking forward to hearing from you. If you get down to well actually let's make sure that you can get into the course to begin with here. So, put this way. And let's go take a look at how we get started here. Where do you go to get going to begin with?
So that's, kind of stacking it here. This then is how you'll access your lectures. And the lecture that I'm making for you right now will show up in the course. And there should be, maybe 3 or 4 lectures, probably, 15 minutes long, 20 minutes long at the most. And in those lectures, we're going to find out about building a home with geothermal energy.